At the top of the cable controller, you have a little diagnostic screen. What the screen does, it tells you the status of the boot up and if there's any problems or errors that are in the boot up sequence. So with the display at 0 or an 8, the voltage supply is available, power's on, hardware is initialized of the CPU module. If this state is maintained for an extended period of time, a hardware error exists. So what you'll actually see when you start your CPU up is you'll see a sequence going from 8, 1, 2, 3, 4, 5, 6, 7, and then a little square box. Number 1 will tell you that the hardware is being initialized. Number 2 is a power on self-test. Number 3, firmware is loaded from the compact flash. Usually when that occurs and stops at that area, it means that the compact flash has been damaged. On some of the newer cable controllers, you can't just copy the contents of the CF card. You have to actually call the service department, and they have to get a specially formatted CF card, and they will copy the program from the CF card that's damaged to the new CF card. Same occurs if it stops on number 4. That just means that the firmware was not loaded and that there's a problem with the CF card. Now, what happens if what damages the CF card is a couple things. Number 1, if you have a power surge and there's something being written to the CF card during the power surge, that will damage the CF card. Also, if you shut the power off during boot up, there's a good chance that that can also damage a CF card. It's exactly like a hard drive on a computer where when it's booting up and writing data back and forth, if in the meantime while it's writing the data, it loses power, that data is then lost. Therefore, the index for the CF card is also lost or damaged, and you can no longer restore the CF card. Then you'll have the startup of the boot block is complete. Operating system is initialized and started. Various firmware components such as the I/O system communications are started. Auto start, number 7. If the auto start function is deactivated, a keystroke control key is expected at this point. And with the little 0, the startup has been complete. The CPU is running. L means it's loading an application. Little square is initialized, firmware started to finish. The system is loaded in the program, but found a fault. The system has been broken. If you see 2 lines, then it's a stop function. And if you have a 0 at the end of the bootstrap or boot sequence, then everything is running normally. If you get a B means that the battery is at a point where you need to have it replaced. When you replace the batteries on the CPU, you have to do it with the power on for the above reasons. It's again like a computer. When you change your battery on your computer, you should do it with the power on, or you lose the CMOS setup. If you see an 8, then there's a serious error and there's a system hardware problem. Chances are that the CPU is defective. Different controller faults. You'll see these flash one at a time. So you'll see an E31, for example, for this guy. And that means the FPGA could not be loaded, missing or incorrect FPGA data. Program is on the onboard flash. Again, all of these things are E32, E51, E52, are all different controller errors that you can get while it's booting up. So if you ever see that there's a problem and you can't figure out what it is, you can shut the power off, open the control door, which is the door below the operator, next to the operator door. Turn the power on and watch it boot up. Excuse me, sorry. I thought I disabled my phone, which I did, but for some reason it's still showing up. I apologize for that. Panel screen status and troubleshooting. So if you switch on the power and there's no display on the screen, the green power LED is off and the red LED on the buttons on the panel are not blinking. That means the power supply wiring is not connected, or there's no 24 volts going to the control panel. This was a common problem on the older machines where you'd have a circuit breaker would trip out, and it was, I believe, a 121 circuit breaker. If you switch on the power, there's no display on the screen. The power LED is on and the red LED buttons are blinking. That means the panel is not connected to the CPU module, or the cable is not connected. So there's a cable that goes from the keypad to the CPU. And if you don't get a display, but yet the keypad is working, that means that communication between the keypad and the CPU is not functioning. During boot up, the screen displays a black and white, and you can see the CPU and memory information and firmware not found. That means the CF card is either missing, damaged, or the files are corrupted. Again, if you have a backup of all these files, you can always restore the backup to the CF card by simply taking the CF card and inserting it into a CF card reader, taking your computer, plugging that into the CF card reader, and finding your files for your machine and copy them over just like a regular copy paste type of situation. During boot up, the screen displays a color image, a progress bar in KE Plus version, but cannot finish boot up for a long time. Again, the application files on the CF card are not working. Maybe they're not complete or compiled with the correct CPU type. Again, you just copy the files from the saved program and you should be all set. After boot up, the screen displays a welcome screen or main screen, but cannot switch other mask. That's when you save that status report that was shown yesterday on the user page. After boot up, you cannot switch the motor and start any movements. When the alarm masks, there's a watchdog error. Again, save the status report and send it to the service department. There's a couple different types of CPUs in these machines. You have a 4030, which are the older type. You have a 1075, which is the non-touchscreen version. You have a 2880 and the 2580.
Excuse me, you cannot see anything.
Yeah, nobody can see your screen. You need to share your screen.
Oh, I'm sorry. Man, when I got that call, it must have kicked me out of it.
It's been like that for 5 minutes.
This conference will now be recorded.
Sorry about that. Let's see. Get back there. How's that? Here I can start back. Did you guys get this section?
Yeah.
Okay. All the error codes. Again, if any of you want to have a copy of these error codes, they're not in any of the books, and I can send you this section of the manual. Just send me an email to training@absoluteitn.com. And I will send you this section of the manual, which isn't found anywhere else in any of the other troubleshooting manuals. Israel, can you mute your microphone, please? Thank you. So again, this is a 2880 CPU. We have a 4030, a 1075, and a 2580. This will go through and tell you there's a sticker on the CPU itself, gives you a little information, revision numbers, product name, the serial number, connection, voltage, etc. Again, this is more identifications. This is another type of CPU that we have. As you can see, you have all your digital outputs at the top section, and all your digital inputs are at the bottom section. Then you have your temperature inputs, your analog signals in the middle, your power, etc. on the side. You have an Ethernet connector. You have a USB port. You have your status for the boot up and your display panel connection. Now these CPUs do have the capability of connecting to the internet, so we can do remote troubleshooting, etc. It's called easy. Hold on, I gotta think about that. Can't think of it. Well, I'll tell you in a little bit. I'll think of it while I'm going along. Again, this is the supply voltage is going to all of these terminals. 24 volts are all the red lines. And you have your negatives going on the bottom. Oh, it's called EZNet. So if anybody ever wants to hook up to the internet where you can actually view the screens on your home computer or your office computer, you can call a service department and you can get a program called EZNet, and they can then install it for you, and you'll be able to view any of the screens, etc., from a remote location. Here's the 2580, a little bit different than the 2880, more compact. Again, it has the same type of signals. You have your digital inputs, digital outputs, the analog inputs, your temperature control, your little boot up screen here, USB drive, Ethernet. This picture's a little fuzzy, but it just tells you what the power is for each of the ports. All your neutrals and your 24 volts. Okay, and this is a little of the same as we covered earlier. All right, changing the battery. On the 2580, the battery is at the top of the CPU up here. Again, you have to do replace the battery with the power on, and it's a 2032. All of our machines use the 2032 lithium batteries. No matter what controller it is, it'll have the 2032 battery. So on this CPU, the battery is located at the top. On this CPU, the battery is located right behind the CF card on the side. Again, on this CPU, the CF card is also located on the top of the CPU up here. To take the CF card out, you just push this little black lever and it should pop out. The only problem is it's very tight in there, so you have to be careful when you're lifting it out and putting it back in, that you put it in and out the same way that it goes in. It only fits one way, but you don't want to force it. To eject this CF card, you just push this little lever here, and the CF card will pop out on that CPU. These are a list of every single error that the controller can put out. So again, if you want this list, just email me and I will be glad to email it back to you. These are not found anywhere except for this demonstration. There's quite a few of them, actually. All right, now the pills. What the pills is, it's the safety PLC that's located inside the cabinet. It's a little orange unit. And what that does is it has a bunch of inputs. So every single limit switch on the machine goes to the pills safety PLC. And what it does inside, it has two CPUs inside of it, which are not the same type. One may be a Motorola, another one may be an IBM. And every single signal that comes in then goes to both of those CPUs. If the outputs are different, then there's a fault that's going to be created from the pills unit. Now, the pills is actually the best troubleshooting unit that you can have, especially if you don't know what the problems are, because it actually has all the limit switches. If the pills is not satisfied, then there's no output, which controls your KA2, KA3, KA4 safety relays that are on the side of the pills. Another thing is you cannot just jump out these signals. These signals are not regular 24-volt signals. What they are their pulse signals. So if you look up here at the top, you'll see T0 and T1. And that's coming from page 36E8. Now we're obviously on page 36. If you look at the bottom, we're on page 36 here. So what we have to do is look at the grid and go E8. And that'll tell you where T0 and T1 are coming from. So what T0 and T1 are two separate pulse signals. These pulse signals are going to go to all the switches on the machine. And again, it will compare the signals to make sure that nobody jumps out any of these signals. So let's follow that through. T0 will go to the mode close switch. Robot E-stop 2. Safety platen 2. Safety platen 1. Machine safety check. Coping door 1. Nozzle cover. Rear door close. Front door close. E-stop. What T1 will go to, it'll go to the extension module feedback. And it'll go all the way to the rear door close, front door close, and e-stop. Now you'll notice that you have 2 different channels for the emergency stop, the front door close, and the rear door close. The reason those are 2 separate channels is because those are the most important safety devices on the machine. If there's a failure with the e-stop or the front door or the rear door, then there could be a potential of somebody getting caught inside the machine and causing either death or severe injury. So they put 2 channels on the e-stop, the front door, and the rear door signals. You'll have this hydraulic safety, so you open the door, S277, which is on the rear door, and S278, which is on the front door, will then open. When that opens, it disables D300 solenoid, and D300 solenoid drops out the hydraulics on the rear half of the machine. So with D300, you cannot run the ejectors, you cannot run the mold open and close signals. You'll lose both of those signals. All right, feedback to PLC signal. That'll give you a alarm on your PLC or your cable controller. You won't a lot of times see all of these alarms occur on the cable controller because they are part of the pills. The pills does not send all the error codes to the safety for the cable controller. It'll only send one signal saying, hey, there's a problem with the machine. You have a abnormal safety alarm. The abnormal safety is usually something wrong with either the rear door, the front door, the e-stop, or something on one of these inputs. How can you tell which one is causing the problem? Simple. You open the door and you look at the lights on these pills. There's a little light on each one of these. So if you see that, for example, this one does not have a light, but you have a light here. So that's going to tell me that one of the switches on the rear door is not being activated. All you have to do is look up and you'll see the switch number 200. You find switch number 200 and that's going to be the problem. Sometimes just opening and closing the rear door will reset the alarm. Try that first. If it doesn't work, then there's obviously a problem with one of the switches. All right. You have a motor starting circuit. And what that's connected to, that's connected actually to the KEB inverter. So that tells the KEB inverter that there's the pills is okay, that there's no errors on it. Again, the way to read these things, A1 and A2 is a solenoid. And if you look below, you have all the contact information that relates to those solenoids. So for example, KA8, you have these 3 contacts. They're normally open contacts, and you can find them on page 27, B5, E5, and F5. You'll have a couple types of errors on this machine. So you'll have I error, an O error, a regular error. And what happens if you have an input error or input fault, you'll see the input light on. And that just means that one of these inputs is not satisfied with the pills. If you see an output error, that means there's a problem with the pills unit itself. Usually you cannot repair an output error. It means that the pills relays, one of the relays in the pills itself is sticking, or maybe the CPUs, two PLCs that are inside aren't comparing properly, so you'd have to replace the pills unit. The error is resettable by taking a jumper on I18 and OA0, just putting a jumper between the two with the power off, turn the power on, wait till the error clears. Once the error is cleared, you can remove the jumper. All right, let's go back to the pills. So this is what the pills unit looks like. And again, you have your power on, your run, diagnostics, fault, input fault, output fault. This is the different fault indicators on the pills. So if the diagnostic light is flashing, the existing user program has been deleted. On the pills unit, there's a chip on here. The chip card is what controls the pills unit as far as the program is concerned. So all the program is held inside that the little chip card. If you have to replace this pills unit, there's two tabs on the bottom. You just hook the tabs. It's off a DIN rail. These connectors disconnect, so all the wires, you don't have to pull all the wires off, you just have to remove the connections. Once you remove the connections, pull the old pills out, put the new pills in, connect all the connectors back on, swap the chip, and turn the power on. You should be all ready to go. On the electric machines, we have something called a yoke hub. With that safety PLC, they actually have to send the unit to Worcester, and I program it so it will be able to take the old program off that machine, and you'll be able to run with the new pills, new yoke hub safety PLC. Sorry. Anytime you see an external fault on a base module, that means there's a problem with the base module and has to be replaced. So usually the output faults have those also. So you see internal fault of the base unit. For all of those, internal fault at the outputs. Fault cascading output until it remains in run condition. So any of those faults, it's usually a problem with the unit itself, and the unit has to be replaced. All right. You can actually hook up and look at the pills diagnostics with a little serial cable. You hooked it up to here, and you can then hook it up to your computer, and you can download the pills program. Not recommended to change the program itself, which is very dangerous. But if you want to look up error codes, you can do that We do have our service guys capability, and we always like to make sure that they have the proper to troubleshoot these PILS units, because it will give you an error code. If you have a fault, it'll tell you what the error codes are, and it'll tell you where the problem is, which is a little bit easier than trying to figure it out by looking at the lights. And it uses graphic user diagnostics. So if you do connect it, you see a green line like this, that means everything's okay. If there's a problem, then the green light will then turn to, green lines, I'm sorry, will then turn to a black line. Questions so far? All right. So let's go through the electrical layout. The first cabinet here is the 480 volt cabinet. That is all high voltage and should only be opened by authorized personnel. The middle cabinet is also 480 volts, and that's for your heat zones. This third cabinet is a 24 volt control cabinet. The smaller machines, the MA 2500s smaller, has another cabinet underneath the clamp. That's for the KEB drive. One thing to remember, if you do have a machine that has a KEB drive underneath the clamp unit, you must keep this area free of boxes and anything. You don't want to block the KEB drive because it's an air-cooled system, and it takes air from the bottom here and up at the top. So if you block that area, it cannot get the airflow, and therefore you'll have a lot of overheat situations with the KEB drive itself. All right, so let's look inside the cabinet. You have Q100 right here. That's your main feed. On the Q100, you also have a thing called a shunt. So there's line 1 and line 2 will have a wire that goes to the side of the Q100 breaker, right here. And what that does is, if you lose power, it automatically will shut the breaker off. So it will not keep the breaker on if there's no power going to line 1 and line 2, which protects the machine from single phasing, etc. From Q100, it goes up to Q103, which is the motor inverter breaker. When you push the button to enable the drive, that kicks in KM1. KM1 is for the KEB inverter. It actually powers the 480 volt end of the inverter. Then it goes to this LC1, which is a line reactor or a one-to-one filter. What it does is reduces the ripples coming in from the power. So if there's a ripple in the voltage, it'll smooth it out. So you'll have a nice 60 hertz signal going to the EMI filter. The EMI filter, which is FR1, reduces any high frequency noise or emissions or any interference coming off of the power that, it just makes sure that the power going into the drive is clean. And next to that, you have the IV1, which is your inverter. For every machine that has a motor, you'll have one inverter per motor. So if you have a machine that has 3 or 4 motors on it, you will then also have 3 or 4 inverters. Down here at the bottom, you have a grounding strap. It is recommended that you use a grounding rod at the machine because the voltage going through a bus system with your ground usually picks up noise. And what happens is the KEB driver relies on 0 voltage, and it gets 0 voltage from the grounding strap. So if your grounding strap has a lot of noise on it, then your 0 voltage reference for your KEB inverter will not have the proper 0 voltage. Therefore, it'll react differently. You'll have different power spikes and stuff, and I mean not power spike, pressure spikes, and things won't maintain a good process. All right, main electrical cabinet. This is the middle cabinet where you have your relays, your fuses, and your contactor panel. So Q121 is the one that controls the 24-volt display panel. You have your power supply here. That power supply is for your 110 volts going to the 24-volt power supply. So it's a transformer, I'm sorry. You have a transformer here. This transformer feeds the nozzle and all the fans on the machine. So keep in mind that the fans are not a 24-volt fan. The fans are 240 volts. These fuses here are for your different zones of your heat. Over here, you'll have your SSRs for your heaters. This is your motor on your heater contactor. So when you press the heat button, that'll engage that contactor. That's where you hear a click. We'll go on because we have more explanations. So KA1, KA2, K1, K2, K8, and K3. The first 2 are for the motors on and off. The second is for the heaters on, and the third one is for your lubrication pump. On the top, you have Q121, which is your T1 transformer power, which again is 480 to 110. And the 110 feeds your 2 power supplies. Circuit breaker T2 is for your 220-volt transformer and your fans. Q111 is for X1, which is a auxiliary power unit, power outlet, X1, X2, and X3. On the back of the machine, you'll see a black box. That black box has a terminal switch strip in it. The terminal strip is 3 auxiliary outlets if you want to use them. Keep in mind that these are not calculated in the full load amperage of the machine. Q131 is the breaker for the lube pump, and Q136 is the breaker for the J5 cooling motor. So the J5 cooling motor, that's a little induction motor that actually cools the servo motor. F11 is zone 1 6-amp fuse. F21 is 2 25 amp fuses. I'm sorry, zone 2. F31 is zone 3, 25 amp fuse. F41 is zone 4, 25 amp fuse. F51 is zone 5, 25 amp fuse. F61 is zone 6, 25 amp fuse, and F150 is a 6 amp cooling fan fuse. This is the electrical drawing for the line reactor. Again, you have line 1, line 2, line 3. Feeding RST is the way it's going to be labeled. It's American wire gauge 2. It's going to a Q103 160 amp disconnect. It goes through KM1 once you turn the power on. Then goes through this line reactor. What the line reactor is a transformer with a capacitor bank. So if the power is too high, it'll store the power. If it's too low, then it'll release it. EMI filter. EMI filter again reduces high frequency emissions to meet the EMC electromagnetic compatibility directives for CE reading. And it helps protect sensitive electronics that are susceptible to high frequency interference. This is the drawing for the motor itself. It's a gear pump servo motor. This motor only turns when there's an action being required. At the top of the motor, you have 2 cooling hoses. So it goes from the little induction motor, which pulls oil from the tank. It'll go through the servo motor, and then it'll go back to the tank on the oil tank. You have an encoder feedback cable. And you have your inverter output for the servo motor, from the servo motor. So the servo motor receives power from the inverter. The output, power output is a frequency based on the desired speed and pressure set points. The gear pump is driven by a servo motor which determines the gallon per minute output. That's why I was saying yesterday when I set up these machines that I don't worry about pressure, because this is a velocity flow type system where gallons per minute output is what it actually is trying to achieve, not pressure. Pressure is just a resistance to flow. So if it does see any resistance, and obviously the pressure will increase to maintain the gallons per minute required for the output. The encoder at the end of the servo motor sends a feedback signal back to the inverter driver card, and large servo motors are again oil cooled. This is the low voltage cabinet. Again, you have your 2 power supplies down here. One's for the input, one's for the output. So you have G1 and G2. This is an amplifier card. There's an amplifier card on the machine to control back pressure. Because the machine has only 1 pump in it, and if you don't have an amplifier card or a proportional valve for the back pressure, what will happen is the back pressure will be the same as the charge pressure, therefore nothing will ever move. So what they do is they put a proportional valve on the back pressure system to lower the pressure going to the back pressure, and you're able to control it better that way. Again, here's your CPU. You have your pills. You have a couple little relays over here. You have your J5 card. The J5 card is the card that actually does most of the work as far as your pressure and flow is concerned. What happens is there's a pressure transducer on the manifold. That signal goes to this J5 card. The J5 card then sends a signal to the KEB drive, which takes that information, compares it to what the actual is trying to achieve, and will control the drive, either increase the RPM or decrease the RPMs according to whatever flow is actually being seen by the machine. Yes, this light will flash if it's good. There's a light in there. It's a red light, and it may look like it's in an error, but it's not. It's supposed to flash. These two gauges down here are for the amplifier card to calibrate the amplifier card for the back pressure. Again, you're going to see your temperature module, TM, your analog input, your mixed analog signals. Then you'll have digital inputs and digital outputs. These two are digital inputs, these three are digital outputs. You have your Ethernet port. You have your little display telling the status. This cable goes to the monitor. This is your power. Again, this has expansion cards for more outputs and inputs.